We're going to use a matrix to solve this system of three equations with three variables. First thing I'm going to do is put my system of equations into an augmented matrix. This one will have one row for each equation, so 3 rows, and then I'll need 4 columns, one for x, one for y, one for z, and one for the constants. And we'll go ahead and fill in coefficients. Top equation, 1x, 1y, 1z. There's the next equation, and the third one. And maybe we'll put in the right numbers. And then the constants over here, we got 2, -3, and 0. There's our augmented matrix for the system of equations. Our goal is to get zeros below the main diagonal. If we can do that, then it makes finishing out solving the system of equations go really fast. So main diagonal starts at the 1, 1 entry, that's 1, and goes diagonally. So I'm going to go this way. There's my main diagonal. I want zeros below the main diagonal. So that's these 3 entries here, the 2, the 3, and the -1. I want those all to be zeros. I'm going to go from left to right. So I'm going to start with the first column and try and get zeros where the 2 and the 3 are, and then move to the next column and get a 0 where the -1 is. Let's look at some row operations that are going to help us do that. In order to get a 0 where the 2 is in the first column, if we think back to elimination, I would want a -2 to add to that +2. Well, if I multiply the top row by -2 and add that to row 2, that'll give me a 0 where the 2 is. -2 plus 2 is 0. I'm going to leave the top row as it is. I'm not going to change it at all. I'm just going to use it and then throw it back. I'm going to replace the second row with the result after I do that operation. We can actually do both of these at the same time. We can think about getting the 3 to be a 0 at the same time. I'll use row 1 again. If I multiply row 1 by -3, that'll give me a -3 to add to my +3 to 0 out that last row. And I'm going to replace again row 3. I'm going to use row 1, but I'm not going to change it at all. Let's see what happens when we do that. Here's row 2. I'm going to multiply -2 times 1 is -2 plus 2. That's 0. We knew that. That's why we picked that row operation, so that that particular entry would be a 0. But now we have to go the rest of the way across the row. -2 times 1 plus 3. -2 plus 3 is +1. Next, -2 times 1 is -2, minus 1 is -3. And finally, in the constant column, -2 times 2 is -4. -4 plus -3 is -7. And we're done with row 2. Now we're going to do same for row 3. I'm going to multiply -3 times the top row. -3 times 1 is -3 plus 3, that's 0. Again, we knew that was coming because we planned it that way. -3 times the next one is -3, minus 1 is -4. Next, -3 times 1 is -3. -3 plus -2 is -5. And finally, the column of constants, Negative 3 times 2 is negative 6, plus 0 is negative 6. So we've done it. We've gotten zeros in the first column there. I just have one more thing to take care of, and that's I want there to be a 0 in the 3, 2 spot, row 3, column 2. I want that negative 4 to be a 0. This time, if I try to use row 1, look what's going to happen. If I try to use row 1 to combine with row 3, that lovely 0 in the first column of row 3 that we worked so hard to get is going to disappear, because I'm going to say something times 1 and add it to that 0. Well, I don't want that. I want to keep the 0 at the beginning of row 3. So instead of using row 1, this time I'm going to use row 2. If I multiply 4 times that 1 in row 2 and add to the negative 4, just like we would with elimination, I'll have a 0 there, which is what I want. So there's the plan. I'm going to multiply 4 times the entries in row 2 and add to corresponding entries in row 3. I'm going to use row 2 and then throw it back. I'm only going to replace row 3. Let's see how that turns out. I'm going to cheat and copy and paste so that I don't have to change all those things again. Here we go. So 4 times row 2. Well, technically we're starting over here in column 1. 4 times 0 is 0, plus the 0 in row 3, and I still have 0. Thank goodness, because I want that to be a 0. Now here we go. 4 times 1 is 4, plus the negative 4 in row 3, that's 0. And again, we planned it that way. We knew that was going to turn out like that. We have to finish out the row, though. 4 times negative 3 is negative 12, plus negative 5 is negative 17. And this is the point where you go, negative 17. That's kind of a weird number. I hope I'm doing everything right. And finally, the column of constants. 4 times negative 7 is negative 28, plus negative 6 is negative 34. And this is the point where you go, oh, thank goodness, because that bottom row now says 0x plus 0y plus negative 17z. Well, that's just negative 17z equals negative 34. Well, 34 divided by 17 is a nice whole number, positive 2. So when I solve this equation, I get z equals 2. 1 down, 2 to go. We still need to find x and y. If we back up one row, so I'm going to go to row 2. Row 2 has a 0 where the x belongs. So I have 0x plus 1y minus 3z, but we know z. So 1y minus 3 times z is 2, that's negative 6, equals negative 7. It tries to help me. It's not that helpful. There's what I meant to say. Well, let's see. Add 6 both sides. I have y equals negative 1. 2 down, 1 to go. I'm going to use the top row now. The top row says x plus y plus z equals 2. Well, I don't know x, but I do know y, it's negative 1, and I also know z equals 2, not 12, 2. It doesn't listen that well. And if I solve for x, I have x equals 1. Well, that's all we needed. We have x, we have y, we have z. We have the solution. My solution, x is 1, y is -1, z is 2.